Okay, in our last couple of videos, I went over some of the material in section 4.3 because I prefer to teach that first, so you should start with those videos. We didn't cover everything in 4.3. We're going to go back to it, like I had said in the previous videos. We're going to go back and forth between the two sections. Now we're going to go back to 4.2 and take the right triangle trigonometry for sine, cosine, and tangent that we know and translate it to circles. And the idea is, you'll notice I already have the basic sine, cosines for 30, 45, and 60 degrees that we went over last time, written on the top of the board because we're going to use those here. This circle right here is centered at the origin, and it's what's called the unit circle. Essentially what that means is it's a circle of radius 1. What that tells me is if it's a circle of radius 1, that's the point 1, 0. That's the point 0, 1. This is the point -1, 0. And this is the point 0, -1. So we have those four basic points that are easy to find, but we'd like to be able to find other points on our unit circle. And there's this trick we can use because of the way trig is defined and the way we defined our right triangle trigonometry. Suppose I pick a point right here. And now I draw a line from the center of the circle to there. We're going to say that this angle right here is 30 degrees. Now I want to try to find the XY point right here on the circle that relates to that 30-degree angle. Well, the only trig I know so far is trig with a right triangle, and I don't have a right triangle there. But what I can do is draw a vertical line straight down from this point. Notice it's inside of the circle. Now that's a right angle right there, which means now I have a right triangle. So now this point, I guess we can call it XY. I just want to figure out what the XY values are there. This is clearly the X value. This is clearly the Y value. Well, what's the value of the hypotenuse right there? This line segment goes from the center to the edge of the circle. That means it's a radius. We said the unit circle had radius 1. So that side is 1. Now I can just apply my trigonometric ratios that I have written up there. That's a 30-degree angle. So say I want to find sine of 30 degrees. We know from our triangles, sine is opposite over hypotenuse. So now I just kind of substitute in. I know by definition sine of 30 degrees is 1/2. And then for this triangle, the opposite side of here is y, all over the hypotenuse, which is 1. But y over 1 is just y. So now I get 1/2 equals y. Well, then that tells me y here is 1/2. So the value of y right there is 1/2, which is just the sine value of 30 degrees. If I want to find the cosine value of 30 degrees, I can do the same thing. Cosine of 30 degrees is adjacent over hypotenuse. When I substitute in what I know, the cosine of 30 degrees is √3/2. That's equal to the adjacent side, which is x, all over the hypotenuse, which I know is 1. So that just goes away. And I get that x equals √3/2. And now I know the value of that point. And the trick here is the wonderful, beautiful mathematical trick going on. All the points on the unit circle are just the values of sine and cosine for the angle you create when you form an angle with the center of the circle. The x value of the point is the adjacent side of the triangle. The adjacent side is the cosine. The y value of the point is the opposite side of the triangle. Opposite goes with sine. So now if I kind of grasp what's going on, I can find a whole lot of points on the unit circle. Suppose I draw another angle right here, a 45-degree angle. So now this angle is 45 degrees. What's that point right there? Well, let's see. If I want to find sine of 45, well, it's just going to be, when I draw my triangle, it's going to be opposite over hypotenuse. But the hypotenuse is 1, so the sine of 45, which I know is root 2 over 2, is going to equal y. The cosine of 45 will just be the adjacent over the hypotenuse, which is just x, because the hypotenuse is 1. So the cosine of 45 will also be root 2 over 2. So if you learn these, we mentioned before, you have to have these memorized. There's a reason for it. If you know the sine and cosine of 30 degrees, 45 degrees, and 60 degrees, then you can immediately find these points on the unit circle. The sine values give you the vertical part, the y. The cosine values give you the horizontal part, which is the x. So maybe the last one we'll go over right now. Suppose I look at a 60-degree angle. What's this point right there? Well, we know the x value is the horizontal. That's the cosine of 60 degrees, which is 1/2. The y value is the vertical. That's the sine. That's root 3 over 2. And there we go. We actually get a lot more information about the whole circle just using this idea right here. So maybe to clean it up a little, we'll erase it and draw it. And now we've essentially established that for any angle that I draw, all the points on the circle relate to the sine and the cosine of that angle that I drew. So now, what if I wanted to find the sine of 0 degrees? Well, if I just draw a 0-degree angle, what's the value of this point right here? It's on the unit circle. We know it's 1, 0. But then that tells me we know the sine is the vertical part, which is the y value. So what's the sine of 0 degrees? 0. Because that's the point on the circle. What's the cosine of 0 degrees? Well, the cosine is the x values of the point. So the cosine of the 0 degrees is 1. If you're kind of following me, what's the sine of a 90-degree angle right there? Well, this is the point 0, 1. We keep saying the sine is the y value. So what's the sine of 90 degrees? It's the y value of that point, which is 1. What's the cosine of 90 degrees? It's the x value at that point, which is 0. So we see we get a lot of information out of this basic understanding of right triangle trigonometry and then applying it to a circle. There is one other thing we can do, and again, I'm going to erase my triangle and redraw it. And I know we've covered a lot in these few videos that I've made, and your book doesn't actually cover the next thing we're going to look at right here until section 4.4, which is, again, one of the reasons why we're kind of skipping around to get a basic foundation, and then we'll fill in a lot of the other ideas and applications once we have this foundation. But if we have a unit circle, you can have what's called a reference angle. And as far as a reference angle goes, suppose I have 150 degrees. So if I draw that angle right here, there's my horizontal, 150 degrees. Let's see, that's 90, that's 180. So 150 would be like right about there. Well, a reference angle is an acute angle, an angle between 0 and 90, that has the exact same measure from the horizontal as the angle that you drew. Which I know sounds a little bit confusing, but essentially the idea is, if we look from the horizontal, if this is a 150-degree angle, we know horizontal is 180, so this angle right here is 30 degrees. That's my reference angle, the 30-degree angle over here. There is a reason for this, which we'll use in 1 second, but to kind of make sure we're clear on it, Suppose I had 315 degrees. What is a reference angle associated with 315 degrees? Well, if I drew 315 degrees, I would start here, and 315 degrees, I go all the way around to right here. That's 315 degrees. So what's the reference angle associated with it? Well, it's the acute angle from the horizontal, which would be this one right here. The whole circle is 360 degrees, that's 315. So if you subtract them, you get 45 degrees. So the reference angle associated with this equals 45 degrees. We'll spend more time going over that in section 4.4, but we want a rough idea of it right now because it can actually help us. Let's see. If I have my unit circle, and suppose we go back to my 150 degree angle, right here. We know that this is 150 degrees, which makes this 30 degrees. What if I want to find sine of 150 degrees and cosine of 150 degrees? Well, we know from what we just did that if I can find the value at that point, the sine will be the y, the cosine will be x. But this is a circle and everything is symmetric, which means if I take this 30 degree angle and then look at its reference over here, this point, well, what points did I have at 30 degrees? Let's see, cosine of 30 degrees was root 3 over 2, so that's my x. Sine of 30 degrees was 1/2, so that's my y. Since the circle is symmetric, this has to be the point root 3 over 2 and 1/2. The only difference is the sign at those points. In this quadrant, x is negative, so that's negative root 3 over 2. Y is still positive, so it's 1/2. And now I immediately get sine of 150 degrees. Well, that's the y value, 1/2. Cosine of 150 degrees, that's the x value, negative root 3 over 2. So using these reference angles helps us a great deal. If we understand the basic values of sine, cosine for 30, 45, and 60 degrees in the first quadrant, we can now expand it to all 4 quadrants when we combine this reference angle idea. So really quickly, we'll draw one more circle. Suppose I have this unit circle and I want to find sine of 240 degrees. Well, first I draw my angle. Let's see, 90, 180, 240 is down here. So I want that right there. I need to find that point, and then I'll have my sine. We know it's the y value. So, well, let's see, what's the reference angle? If that's 240, and that's 180, this angle right here is 60 degrees. Which means my reference angle is 60 degrees over here. So what are the values at 60 degrees? Well, I think for 60 degrees, we said the cosine of 60 degrees was 1/2. The sine of 60 degrees was root 3 over 2. But we check our signs. This is the third quadrant. X is negative here and y is negative here. So there we go. And now we know sine is the y value. So what's the sine of 240 degrees? Negative root 3 over 2. Understanding this is really important. We're going to use it a lot, repeatedly throughout the semester. If you can grasp this, how to plot points on a unit circle, using sine and cosine from our right triangles, and then using reference angles to go to different quadrants, then most of what we will do this entire semester will be a lot easier and a lot more trivial, because it's just applying that idea over and over and over again. So make sure to practice it until you have a good understanding of what's going on.